Hello everyone, my name is CilkR, and this is my presentation on CilkR, a simplified, extensible Cilk runtime for research. So we all know at this point what Cilk is. Here's the stereotypical favorite program using Cilk. But as a quick review, it extends C and introduces two keywords, Cilk spawn and Cilk sync. They do exactly what their names imply. Now, the reason Cilk is interesting is because of its scheduler, which uses a work steering algorithm to divide work among the various workers. Here workers are just threads. Each worker saves its state in the deck upon reaching a spawn. Another worker can pick another worker and try to steal the work, and this thief will then attempt to transfer the suspended state from the victim to its own deck. The thief will then resume execution of the stolen state. Now let's say we want to modify the runtime. Maybe we're a researcher and we have a new idea of how to better save the runtime state. Or maybe we're a teacher, we're teaching a class like 6172, and we want to cover the runtime. That overview is how I didn't want too complex. Now, obviously there will be more details, but that still shouldn't be too hard to cover, right? Well, the most used runtime for Cilk is the Intel CilkR runtime. That begs the simple question, is CilkR simple? Well, the answer is a resounding no, it isn't. First off, CilkR is large, so let's just look at the lines of code. We ran SRC count on it, and we got this result. 5,100 lines of C code and about 3,300 lines of C++ code. Also some random XML. No real idea where that is. But that's with no documentation, and that's still already quite large. As it looked with documentation, we ran CRC on it and we got 1,100 comments. That's more than there is code. Now this isn't quite enough for comparison because CRC is encoding a few extra files, but we're still looking at more comments than there are code. But hey, that's not necessarily bad. That just means it's well documented, right? No, again, the issue here is that CilkR has some, for lack of a word, spotty documentation. Let's say we want to look into reducers, and we want to see the protocol used while implementing them. Where do you think that would be? Maybe it's on its own dedicated page. After all, it sounds like an important thing. Should get its own file, right? No. Well, then maybe it's in the header file, where reducers are defined. That's pretty standard coding practice, right? Apparently not. Well, maybe it's in the implementation file. A few people do that, not normal, but certainly not abnormal either. Again, no. So what about line 3252 of the scheduler file, which, as you can see, is already a massive file, but that's where it is. And on that note, what even are reducers? After all, they never came up in that overview. Well, they're one of many non-core features on which a lot of code is spent, and for the most part, for the beginner, these features don't matter. Clearly, we need a simple, possible runtime to remedy the issues with CilkR. Any attempt is going to need to meet three criteria. First, it cannot perform comparably to CilkR. Second, it cannot be short, less than 5,000 lines of code. And third, it's got to be simple. That's a bit subjective, but at the very least, it's pretty clear when something isn't simple. Now, our attempt, as we said, is called CilkR, and it derives from two previous runtimes. First is obviously CilkR. For all its issues, it is the industry standard for a reason. It'd be kind of stupid to throw everything out. The second one is called CilkM, which is an experimental version of the runtime, which was very simple. At one point in time, it was even shorter than CilkR. That was how we got the 5,000 lines of code comment. Second is that it used a tool technique called TLMM, or thread over memory mapping, which sadly only runs on an old version of Linux. In fact, no MIT computers can run it anymore. Now, while we were implementing CilkR, two areas cropped up that needed particular care. The first has to do with when a thief resumes a state. We need to be able to not copy the victim's execution stat. Second is the actual bookkeeping behind how we handle steals. So the stat detail basically arises from the fact that the function may have multiple carries running at the same time. So in this example, with this nested list of calls, we need each function to see a different execution stat. Now, a system that implements this usually uses something called a cactus stat, which is called that because if you flip it upside down and really squint, it kind of looks like a cactus after being exposed to nuclear fallout. Now, CilkR implements a cactus stat by using fibers, large segments of virtual memory. We can, by setting the RSP pointer to the base of the fiber, continue execution on a new fiber. CilkM, in contrast, uses that technique called thread over memory mapping, which lets us manipulate how the virtual memory maps to physical memory on a per-thread basis. As such, by remapping to different physical pages, we can continue execution on each worker at the same virtual address. That way, the workers literally see the different execution stacks given in B, as opposed to with fibers where it is similar looking but not contiguous. Now, the details on merge stealing are thankfully a lot more standardized. There's a pretty standard implementation, which you've all seen before. Each worker breaks its call stack into several smaller chunks, divided by potential spawns. These are grouped into stackets, with the divisions being actual spawns. And the stacklets are stored in a spawn deck, just like in this image. What they refer to as a call stack is what we are calling a stacklet. And thieves can steal and resume execution from the head of another victim's spawn deck. Now, CilkR implements these areas as follows. It uses the fiber-based implementation of character stacks, and it uses CilkR's implementation of work stealing, and indeed the scheduler in general. Now, merging these caused a number of issues. Among others, we found out that GCC really doesn't like it when you manipulate OSP. We also found out that CilkR's scheduler subtly varies from that standard implementation. And also, Cilk+'s fibers lack any type of usage documentation. However, on May 13th at 10:31 a.m., yes, I was paying attention, we got CilkR v0.0.1 alpha working. So let's go back to those questions, those criteria. Is CilkR fast? To test it, we computed the furthest Fibonacci number using a serial implementation, a version using Cilk+ on 2 workers, and a version using CilkR on 2 workers. So the serial version took 0.338 seconds. That was compiled on O2, and obviously it wasn't using a Cilk runtime. Cilk+ took 3.4545 seconds, again compiled on O2, using the standard runtime, so who knows what that was compiled on. Now that's a bit terrifying because it's already a 10x speed down. Now that actually sounds good for us. We're using a much shorter system, so we should be able to beat that, right? Yeah, no, we actually did worse. 5.5 seconds, or 1.5x slowdown over Cilk+, everything compiled on O2. However, we're actually fairly happy with that. CilkR lacks a number of things Cilk+ has, such as proper usage of inline code. This was as a result of how we refactored the code to work. And second off, it's not integrated into the compiler at all. We're pretty sure that's how to make up most of the difference as we continue working forward. Now, is CilkR short? As you may recall, we ran SLOC count on Cilk+, and we got around 8,500 lines of code, which is fairly large. CilkM, when we did the same thing, actually came in a bit higher at 9,200 lines of code. Most of that was in C, and there was a bit of inline assembly. Now, a fair amount of that line was due to new features added later on, but still, it's fairly sizable. So, how did CilkR do? Did we beat that 5,000 line of code reference? By quite a bit, at under 2,000 lines of code. Ours is the shortest by far. Now, is it simple? Well, we sure think so, but that may have something to do with the fact that we've been doing nothing but coding it for the past month plus. Now, the code is definitely organized better. We've split things off into different files to better represent what code is where, and to prevent any monster files, like the scheduler file in Cilk+. That being said, the documentation is still incomplete. We just ran out of time on that. So, to review, we implemented a new Cilk runtime called CilkR. It performs relatively comparably to Cilk+. We think we can get it to match fairly quickly. It's short, less than 2,000 lines of code, and we at least think it's simple. So beyond this, beyond fixing bugs, two of our most immediate goals for CilkR. First off, as we said, we want to get the performance up to par with Cilk Plus. Second off, we want to implement reducers, those tools we mentioned before, and we also want to add support for exceptions. Combine these would more or less round out the necessary features for a full Cilk runtime. So, here are the papers we reference. Thank you for your time.